Hello everyone, nice to meet you again. I'm Hyunjong Lee, and this is my second lecture, and the title is Fundamental Understandings of Digital Data and Superimposition. So, how do you think much do we know about this digital data in this era of digital dentistry? Like it started around 1979, like 40 years ago. And there are so many conferences about digital dentistry, as you know, and mostly deal with new equipment or new device like new updated intraoral scanner or CAD software or 3D printer and so on. So new intraoral scanner or new software is the main point of this digital dentistry. But I think there are lack of basic and fundamental lecture a bit. It's important to know how the three-dimensional 3D surface is generated and how it is consists of. It's important. So I have been studying various 3D analysis using digital softwares these days, and I have handled lots of STL files, standard tessellation language file or stereolithography file. So I suddenly thought that we need to know a basic and fundamental feature of digital model for sure. So many dentists don't know about 3D digital model, what it consists of. Actually, we are familiar with this kind of stone model made of dental gypsum. It's not that difficult to understand this dental stone, because we can grab and we can touch it. And we studied this chemical formula in the lecture of dental materials a long time ago, I guess. As you can see, this is the dental stone. This is the same image of gypsum particle and this kind of various color of gypsum powders. We know this is the dental stone. But how far do we know about digital 3D model? When we use intraoral scanner, it shows only nicely rendered 3D view. Just it looks nice. As you can see in this slide, there are many steps of workflow before we obtain a good looking 3D intraoral image. Thanks to the development of CPU and graphic card, the 3D intraoral rendered image will be closer. It's really closer to real view. It looks really nice. However, it does not guarantee that a good looking 3D images are always an accurate image. Sometimes when it looks good, it isn't accurate at all sometimes. So we need to know about whole process, how it is generated. So as you can see here, the first step is acquisition of point clouds. I will show you later. And then mesh generation, projection, clipping, hidden surface, shading, mapping. So there are really 7 steps for this real-time rendering process. So let's think, what is digitalization? So we can search it in the Google and we can see the digitalization is the conversion of text, picture, or sound into a digital form that can be produced by computer. And actually, nowadays, there are really many kinds of 3D device for 3D digitalization. So as you can see, this is the lab scanner to digitize the gypsum model to 3D. And this is the well-known intraoral scanner. And yes, as you can see, it's nowadays not that difficult. It's easy to get a 3D image, and by just one clicking, we can get this kind of good-looking 3D tooth images. Let's see. There are another kind of scanner like this handheld scanner, and it's really quite accurate, and its field of view is quite large, so it's really good to scan the facial scan. Mostly it is widely used in industrial part, but it also used for dental research or dental clinic to get a facial image. So there are many kinds of scanners like this, and this is intraoral scanner, And we widely use for scanning the tooth and gingiva for intraoral use, but actually it can scan whatever you want, like fingers or something. And this is another small equipment for facial scanning. You can see a small equipment and it can be connected to your smartphone and just you can easily get your face image. And also it can be integrated, it can be imported to the exocad, the most widely used CAD software. And we can really directly deliver the patient facial information, and it's really good when they work for anterior processes. We can see the midline of patient, we can see the interpupillary line, and yes, many things, lip line, smile line, and so on. So it's really distal era of distal dentistry, and we are handling many kinds of these 3D surfaces, facial scanner from intraoral scanner, lab scanner, something. They are all three-dimensional distal data. Like the movie Matrix, when the Neo, when he got his real ability, when he opened his eyes to really, he could see the truth of the world. So like Neo, let's see the distal model to getting closer to its nature as it is. Let me show you this. We can open an STL file using Notepad in program in your computer, and I recommend you try this. You just need to open the Notepad program in the window, then you can just drag and drop a certain STL file. Then you can see this unreadable information. This is most widely used STL binary format. There are so many unreadable things here we cannot read, but computer can read this. And now we can read the information of this 3D data. This is the same STL file, but the format is not binary file, but ASCII file. The ASCII file we can read. So this format allows us to read something, and as you can see, the 3D model consists of all of these numbers, all of these small triangles, and these connected triangles represent 3D information of the surface. So this is STL ASCII format. I mean, it's the nature of distal surface. It's just number. So every single this small triangle consists of like this vertex. Triangle consists of 3 vertex, vertex 1, 2, 3, and each vertex has x, y, z number in the 3D coordination, and the facet normal x, y, z. So all of these numbers represent one single triangle. So this is process of distalization. We just can see nicely smoothing teeth when we scan using intraoral scanner, and the tooth is really smooth and it looks good. But the nature of this is like this. There are so many points. Number D, all of them are cloud points. And this red dot is the selected points. So let me show. There are not exactly generated onto the real tooth surface. Instead, they are a bit spread out within range of error, as you can see here and there. When we're scanning metal surface, kind of very shiny surface, the cloud points would be more spread out. Yes, there would be outliers there, here and there, like this. And the computer, during the process, lots of cloud points does not guarantee the higher accuracy, as you can see. During the mesh generation process, the outlier, like this red dot, outliers would be removed automatically. And after that, another lots of points will be removed. The points that are considered reliable will be remained to reduce the process time and file size depending on process algorithm. The algorithm only remained this number of points. So let's see, when we get like 5,000 of point cloud, but during the process only like 10,000 of point clouds only remains, something like that. So now by connecting these point clouds, we can generate 3-dimensional mesh. consists of small little triangles as you saw previously. So actually this is the real nature of 3D surface. This is the lower first molar, and you can see there are so many small triangles here and there. So this is the STL file, STL format, and basically STL format doesn't have color information, but another format like PLY or the other format can have color information together. So stereolithography or standard tessellation language, or we can call it standard triangle language. So let me show you a short video. I think this shows the process of mesh generation in facial scanner, and it's really good to understand. Like as you can see here, there are the mesh and there are many outliers of cloud points, and all of these spreaded points will be removed. And as you can see, the 3D surface, one thin 3D surface is just generated, the STL file. And after that, the color is coded on this surface, smoothed and coded, you will see here. Actually, this is the same to the intraoral scanner. Let me give you two questions. Would 3D data be deformed when they are exported or imported many times? So it means when we handle the 3D data, 3D STL file, we can export from one software and then we can import to another software for many purposes. And if we import many times, then would it be deformed or not? So basically, even if you import or export like 10 times or like 100 times, basically the information, the number doesn't change. So actually it doesn't that matter. Sometimes it could be matter, but basically number as it is doesn't change. And the second question, is there any relationship between number of triangle? We can correlate resolution and accuracy. We might think the high resolution guarantee the high accuracy, but actually it doesn't. Even if we measure 100 times with an inaccurate ruler, the result will not be accurate. So the program just divide one triangle from one triangle to many triangles. It doesn't guarantee the accuracy, and it just only increase the file size. So let me show you one study, and they performed this study to find out accuracy and resolution of 3D data using 5 different intraoral scanners. And they found out that there are no relationship between resolution of points. Resolution means the number of points and the accuracy. If we make many numbers of points, it doesn't, as I told, it doesn't guarantee make the accuracy get increased. So these are real actual 3D surfaces, but usually we don't see this kind of little triangles usually. But we need to know actually this consists of all of these small triangles. So we just change some numbers in program, and we can, like this, from this to this, we can just divide the triangles. But as I told, it doesn't guarantee to make the accuracy higher. These are the nature of 3D surfaces. We need to know the understandings of superimposition. So it's really basic and fundamental things to handle or to understand digital dentistry. So it's really important and really primary function, the superimposition. Let me show you an example. There are one upper molar and one lower molar, and they are bited. So let's see the process of intraoral scanning. So first, the patient opened the mouth, and we can scan the upper tooth and surrounding gingiva. So this dashed line is scan surface, and after that, this is scan surface for upper, and after that we can scan lower. So we get two different files, upper and lower, but it should be aligned properly to get information of bite registration. So when we take the bite registration, we can only scan only buccal surface here, as you can see. So after bite registration, upper model is going to here, stick here, and lower model go here and stick here. So the upper and lower scanning surface are superimposed to buccal bite registration surface using only buccal area. Therefore, when there would be some error or some little hole, and that holes or errors is located, if they are located in lingual surface, actually it doesn't that matter in terms of superimposition, because superimposition is performed only using buccal surface. The process is performed using so-called best fit algorithm. It's just automatically stick. We don't need to care about this mostly. So there are really, actually this best fit algorithm is really mathematical theory, but I won't explain about this in this lecture. So anyway, best fit algorithm using identical surface. So when we scan, really we need to take a good scan for buccal area to get a good best fit algorithm. So after that, this real is turned to distalized information, and we can now handle whatever we want in this CAD software. Let me show you another case of superimposition. When we take facial scanning, it's a bit different to superimpose all of this 3D data, facial scan and intraoral upper scan and lower scan. It's not easy to superimpose. So we can use some kind of jig, something like this, and we can scan. When we perform facial scan, we can scan facial surface, include this some kind of jig, some structure like this. It's the frame. This is the frame, and we need the same identical surface. So this area is the same with whole facial scanned data, and this structure is same to the jig which is connected to the intraoral circumstance. So using this frame is for outer surface facial scan, and this frame is for inside surface, the intraoral. So using this frame, the upper model can be aligned like this, and using this surface, the facial scan can be aligned to this. And after that, we can just remove this frame. Then now we obtain the upper model and facial surface, which is well aligned, and it has meaning, it has information now for diagnosis. The final example is superimposition of scan body, implant scan body. When we perform the implants installation, yes, implant it is inside the bone and we cannot see. But when we connect this some kind of scan body, then we can see this part in intraorally. We cannot see in this part because it's inside bone, but this part we can see. And when we scan, the outer surface of tooth and outer surface of this scan body is scanned just like this. So we get this kind of frame, some three-dimensional, some frames. And here, this is the library data, which is combined to scan body and implant. Using this identical part, it can be stick here. If there is a little bit some errors in the scan data on implant scan body, then this library data could be not accurate. It's really important to take a good scan body area. And after that, we can remove the scan body, and now we can get the whole data of implant and tooth data. There is some clinical points when we scan the scan body intraorally. Usually or mostly, it's not that easy to scan all of the surface of scan body. Especially, it's easy to scan buccal side and occlusal side and lingual side because no interference. It's easy to scan, but the mesial side and distal side, it's not that easy because of the adjacent tooth. The light of scan is not very sufficient to get good image of distal surface or major surface. So there would be a hole on the major or distal, and maybe buccal, occlusal, lingual would be really well scanned. However, in this case, so even we have some holes in major or distal, actually we performed several studies, even we have some holes in major and distal, accuracy of superimposition was not that low. Yes, we couldn't find the statistical difference between really well scanned whole scanned scan body and majorly distally opened scan body. Actually, it's not that matter. And when it's open on major surface and distal surface, we shouldn't close them automatically, because when we perform automatically whole close, that reconstructed surface is not that accurate. So it can make error compared to just not connected surface. This was the last example for the superimposition, and so this is actually it's the end of my lecture, and I showed you the fundamental of three-dimensional data, how it is constructed from the first step of scanning to the last step of processing. So we need to know the fundamental and basic theory of this 3D distal surface in this era of distal dentistry, I think. And also the superimposition is really important part in distal dentistry. So yes, this is the end of the lecture, and thank you very much, thank you for your attention.